Alright, let's continue our conversation on trigonometry by talking about reciprocal functions, and let's review all of them while we're here. So there are 6 trigonometric functions for right triangles. I put that because later on, or maybe not in this class, but probably in this class, you're going to learn that there's other ways to define sine, cosine, tangent without using opposite, hypotenuse, and adjacent. So when I say for right triangles, I mean we're only going to take the sine, cosine, tangent of angles that are less than 90 degrees, and they are angles in right triangles. But trig is a lot more than that, but this is kind of where we start. Alright, so quick review. In a right triangle, theta is one of the acute angles, so theta could be that angle as indicated, or this angle right here. Alright, but once you establish theta, the side across from it is opposite. The side next to it, that's not across from 90, is the adjacent leg, and the side that is across from 90 is the hypotenuse. Given those definitions of those legs and sides, the sine of an angle is opposite over hypotenuse. Alright, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Now reciprocal, you might be most familiar with it as flipping a fraction, sort of like when you find slope. If the slope of a line is, let's say, like 2/3, alright, so I'm going to sketch a line that has a slope that looks like 2/3. Alright, you probably know that a perpendicular line is going to have a slope that's the opposite reciprocal. So opposite means it's going to go from positive to negative. Reciprocal means we're just going to flip the fraction. So a perpendicular line would have that slope of negative 2/3 because 3/2 is the reciprocal of 2/3. Okay, so in trig, that means the same thing. The reciprocal of sine is cosecant, so its definition is just hypotenuse over opposite. Alright, same thing with secant. That is the reciprocal of cosine. So that's just going to be hypotenuse over adjacent. And tangent is the reciprocal of cotangent. So cotangent is going to be adjacent over opposite. Now the way I remember how to pair those up, alright, and there's different ways to pair up the 6 trig functions. We're going to learn 2 of them in this video series, but the first way is reciprocals, alright, as we just talked about. The way to remember to pair up the reciprocals is that, or how I remember it, is the first letters never match up. So like if we look at tangent, first I know the reciprocal of tangent is cotangent because they both have that word tangent in it. And notice how C and T are different first letters. So that leaves us with secant and cosecant. So using that method that the first letters never match up, alright, I know that cosecant is the reciprocal to sine because they have different first letters. And cosine and secant have different first letters, so they're going to pair up as well. Alright, so if you remember it that way, that the first letters never match up and tangent goes with cotangent, that's one way to remember these pairs. Okay, so now let's practice using the reciprocal functions in this first example. So a lot going on in this first example. Let's read it first. It says in triangle ABC, where C is 90 degrees, A is 3 and B is 2√5, find all 6 trig functions of angle B. Alright, first thing I want to talk about is when you name triangles with the capital and lowercase letters, okay, the capital letters are always going to be the angles, and the lowercase letters are always going to be the sides. And the side across from each angle is going to be the same letter, but lowercase. So I'm going to redraw this and color coordinate it so that makes sense. Okay, so anytime you label a triangle with letters, you want the capital letters to be the angles and the lowercase letters to be the sides. And the same letter corresponds with the angle and side pair that are opposite of each other. Alright, so when it says that C is 90, we know that it's a right triangle, and we're going to call this 90 degrees. And it says that A is 3. Now, it didn't give us units, so we'll just assume it's just 3 units. And it said that C is 2√5. So now we need to figure out what B is, and we're going to do the Pythagorean Theorem. Now, this was conveniently named triangle ABC, and that corresponds with the Pythagorean Theorem, but the Pythagorean Theorem just needs, so that a squared plus b squared equals c squared, c just has to be the hypotenuse. So I could have renamed these angles and sides, but I would still set up the Pythagorean Theorem the same way. Alright, so I get 9 plus b squared is equal to 2√5 squared. So make sure you square the whole thing. So 2 squared is 4, root 5 squared is 5, so that's going to come out to be 20. Subtract 9 on both sides and I get 11, so b is going to be root 11. Okay, now I'm going to find the 6 trig functions of angle B. Okay, so sine is going to be opposite over hypotenuse, so we get root 11 over 2√5. Okay, cosine is going to be adjacent over hypotenuse, so we get 3 over 2 root 5, and tangent's going to be opposite over adjacent, so root 11 over 3. Okay, now I should really rationalize this, and I know it's kind of a weird place to stop, but I'm going to stop this video and we'll pick up with this example in the next part.